Okay, explicit formula. Today we're talking about the explicit and recursive formulas. Once again, these look really, really scary. They're actually not. They're not too bad. All we have to do is know what A sub 1 is in D or A sub 1 and R. Okay, and we'll talk a little bit more about where they come from and different things like that. The explicit formula, though, is a formula used to find the nth term of a sentence. That means that if I have the explicit formula, I can plug in any number I want. So say I want to find the 50th term. I can plug 50 in for n, and it will tell me what the 50th term in the sequence is. Okay, so this is something you probably want to get out your highlighters. And we want to highlight these two things. You need to know these. So you've got your arithmetic sequence. I'm trying to figure out where my highlighters are on here, but I can't find them, so I'm not going to use them. So we have our arithmetic sequence right here and our geometric sequence right there. Okay, and we're going to go over to the next page and look at them again. Okay, and I have very exact directions here on how to find the explicit formula for each the arithmetic and the geometric sequence. So first of all, if you're trying to find the explicit formula for an arithmetic sequence, first of all you just find the common difference D and A sub 1, which everybody in here already knows how to do. Okay, and then you just take D and A sub 1 and you substitute them in to this formula right there. Okay, same thing for if it's geometric. If it's geometric, we want to just find the constant ratio R and A sub 1, and then we take R and A sub 1 and we substitute it into this formula right there. Okay, now it looks like a scary formula. We're actually going to talk about, though, where that formula came from. So where did the explicit formula come from? How did it show up? So first of all, we're going to go ahead and look at an arithmetic sequence. So we have 2, 5, 8, 11. Okay, very simple arithmetic sequence. And we can see that we are adding 3 every time. So we know that D equals 3. We can also see here that 2 is A sub 1, 5 is A sub 2, 8 is A sub 3, trying to squeeze everything in here, and 11 is A sub 4. So below that, you see where it says arithmetic, where A sub 1 equals, it's blank. We're going to, this is what I'm going to be doing. So we're going to be going down that column and showing where the explicit formula came from with an arithmetic sequence. Okay, so I'm going to go ahead and put here that we have A sub 1 equals A sub 1. Okay, that may seem a little ridiculous because obviously it equals itself. But remember that the formula is A sub 1 plus D parentheses n minus 1. So we're always starting with A sub 1. That's where we start. Okay, that's our foundation. Okay, now we're going to look at the next one here, which is A sub 2 equals. Well, how do I get from A sub 1 to A sub 2? So how do I get from here to here? Well, you can see I just add 3, which is D. So I'm going to add D to get there. Okay, then after that, I'm going to say, well, how do I get from, if I want A sub 3, how do I get from A sub 1 to A sub 3? Well, I can see that if I'm at A sub 1, which is 2, then I add 3 to get to 5, and then I add 3 again to get to 8. So I have A sub 1 plus 2 D's that I've added now to get to A sub 3. Okay, A sub 4, which is A sub 1 plus, well, to get from A sub 1 to A sub 4, I have to add 3 D's. And to get to A sub 5, I would have A sub 1 plus 4 D's. Okay, now this is where the explicit formula comes from. If we look at our pattern here. Okay, if I look here, I have A sub 2 equals A sub 1 plus, now remember there's an invisible 1 right there. So I can put in parentheses 2 subtract 1 times D. Because 2 minus 1 is 1. A sub 3 is A sub 1 plus The 3 from the a sub 3, take away 1, gives me 2d. A sub 4 equals a sub 1 plus parenthesis. To get to 3, I take 4 minus 1 times d. And our last one, a sub 5 equals a sub 1 plus parenthesis 5 minus 1 times d. Now I'm going to give everyone a chance to write that down. Okay, as we look this over, we can see a pattern here. So let's start with a sub 2. A sub 2, and I do a sub 1 plus 2 minus 1. A sub 3, and I have 3 minus 1. A sub 4, and I have 4 minus 1 there. A sub 5 gives me 5 minus 1. So now we want to know, where does the a sub n equals a sub 1 plus n minus 1 times d come from? Okay, well, I'm going to just do some quick erasing here and rewrite so we can look at it again. I'm sure there was a clear button that would have made this easier. Okay, so if I have, we're going to go back to the a sub 5 equals a sub 1 plus parenthesis 5 minus 1 times d. If I have a sub n equals a sub 1 plus, instead of a 5 right here, which came from here, I want to take this n and put that right here, n minus 1 times d. And now I have the formula that I gave you at the top of that page for the arithmetic sequence for the explicit formula. Okay, we're going to do this again now, but we're going to do it for the geometric. So my next pattern is going to be 3, 9, 27, 81, dot, dot, dot. It's geometric, so I know I'm multiplying by the same number, which in this case is 3. Multiplying by 3 every time. I'm going to actually write this in here. That's r. So I'm timesing by r, timesing by r, timesing by r, timesing by r. I know this is a sub 1, a sub 2, a sub 3, a sub 4. So underneath where it says a sub 1 equals, we're just going to put a sub 1. And then we're going to look at a sub 2. A sub 2 equals, how do I get from a sub 1 to a sub 2? How do I get from 3 to 9? Well, I just multiply it by r. So it's a sub 1 times r. That's how I get to a sub 2. So to get from a sub 3, from a sub 1, I have to multiply by, well, here's a sub 1. I multiply by 1r. Then I'm at a sub 2. I multiply by another r to get to a sub 3. So r times r is r squared. Okay, so a sub 4 is going to be a sub 1 times r to the third power, and a sub 5 is a sub 1 times r to the fourth power. Give everybody a chance to write this down. Okay, now we're going to look at the pattern. So a sub 2 equals a sub 1 times r to the 2 minus 1, which gives me a 1 right there. a sub 3 equals a sub 1 times r to the 3 minus 1, which gives me a 2 right there. A sub 4 equals a sub 1 times r to the 4 minus 1, which gives me my 3 right there. And a sub 5 equals a sub 1 times r to the 5 minus 1, which gives me my 4. So whatever number n is, I subtract 1 from it and plug it into that form. So let's look at how the general form comes about now. So if I have a sub 5 equals a sub 1 parenthesis times by r, oh, but I don't need a parenthesis there, do I? Times r to the 5 minus 1. If I'm doing a sub n, it's a sub 1 times r to the n minus 1. And that is the formula you have at the top. So that's how the formulas came about. Okay, we're actually going to talk about now how to use these. Okay, so for number 1, go ahead and write those numbers down. Our sequence is going to be 3, 9, 15, 21. We're going to write the explicit formula for the arithmetic sequence, then find the 10th term. I've already told you that it is an arithmetic sequence. Okay, so we don't have to worry about that. If it's arithmetic, we need to first of all find D and a sub 1. So I'm going to give you 3 steps that you can follow every time to write an arithmetic sequence, and then find the whichever term I ask you to get. So everyone here right now, find D and a sub 1. Okay, so for D, you should have 6. And for a sub 1, 3. Our next step is to write the explicit formula. We know that a sub 1 equals 3 and D equals 6. So we're going to plug that into our explicit formula. So our explicit formula is a sub n equals a sub 1, which is 3, plus D, which is 6, parenthesis, n subtract 1. Okay, now we want to find the 10th term. So all we're going to do is take 10 and we're going to put that in for n. So I have a sub 10 equals 3 plus 6 parenthesis 10 subtract 1. So a sub 10 equals 3 plus 6 times 9. 6 times 9 is 54. 54 plus 3 is 57. So we can say that a sub 10 equals 57. So that means that the 10th term in this sequence would be 57. Okay, here's number 2. I'm going to have you copy that down, and then I'm going to give you about 2 minutes to do that problem on your own, maybe a minute. So first of all, we had to figure out what D was and a sub 1. D is negative 7, and a sub 1 is 8. Now we need to take those and plug those into the explicit formula. So we have a sub n equals 8 subtract 7 parenthesis n subtract 1. So this is our explicit formula right there. The last part is to find the 8th term. So a sub, oops, sorry, wrong one there. A sub 8 equals 8 subtract 7 times 8 subtract 1. So a sub 8 equals negative 41. Okay, go ahead and flip the page now to page 292. And we're going to now talk about how to write the explicit formula for a geometric sequence this time. So we're going to go ahead and do the same thing where we follow the same steps, but instead of finding D, we find R. So our sequence is 5, 15, 45, and 135. So write that down on that line. And then you need to find R and A sub 1. So I'll give you a few seconds to do that. Okay, for R you should have gotten 3, and for A sub 1 you should have gotten 5. Now we want to write our explicit formula. Remember that R was 3 and A sub 1 was 5, so we're just going to plug that right there into our explicit formula. A sub n equals A sub 1, which is 5, parenthesis, I'm going to run out of space here, so I'm going to erase that. R, which is 3, parenthesis, n subtract 1. Then our last step is to find the 16th term. So we have A sub 16 equals 5 times 3 to the power of 16 subtract 1. Now don't forget when you put this in your calculator to put parentheses around that 16 minus 1, or just put 5 times 3 to the power of 15 in there. So you're going to get A sub 16 equals 71,744,535. So don't forget, if you didn't get that number, it's probably because you did not put parentheses around the 16 subtract 1. Okay, I'm going to let you try number 4 now. So the numbers are 80, 40, 20, and 10. If you can't remember what to do, look at number 3 and look at the 3 steps that are spelled out there for you. Okay, let's go through this one. We know that R equals 0.5 or 1/2. And that A sub 1 equals 80. So now we're going to write our explicit formula. A sub n equals 80 parenthesis 1/2 to the power of n subtract 1. Then our last step is to find the seventh term. So a sub 7 equals 80 times 1/2 to the power of 7 subtract 1. And you should get 1.25 or 1 1/4. Now if you didn't get 1.25, you probably forgot to put parentheses around the 7 subtract 1. So if you didn't get 1 1/4, sorry, then try that again. And make sure to put parentheses around the 7 subtract 1. Okay, we're going to start talking about the recursive formula now. The recursive formula is useful when you're just trying to find the next term. You cannot find just any term. You can only find the next term in the sequence. So let's say that you know term 19, then you could find term 20. But you couldn't find anything else using the recursive formula. You'd have to find all of them in order to get there. So anyway, this is really helpful though with computer programming. I know this is used a lot with computers. Okay, so these are our two recursive formulas here. We have the arithmetic one and the geometric. So here's our arithmetic. And here's the geometric right there. And they look kind of scary, but they're not. Once again, all we're doing is we need to find a sub 1 and D or a sub 1 and R for these. Okay, so let me explain a little bit what's going on here. So what we have is, I'm going to see if I can zoom in here just a little bit. So let me get rid of those. So the first one here is our arithmetic one. And what I'm looking for is I'm looking for what a sub 1 is. So we're going to put that right there. Then we are also looking, so we have a sub n. So any term, the way I can find any term is I take a sub n minus 1, the term before it, and add d to it. Now this only works for n is greater than or equal to 2. The reason why we say that is because you have to know what a sub 1 is in order for this to work. Okay, so it doesn't work for the first term, it only works for the second term or higher. Okay, and the same thing here with the geometric. We're going to find a sub 1, put that right there, and then also find out what r is and plug that in. So to find any term, we take a sub n minus 1, and times it by r. Okay, let's go ahead and practice this. Okay, so we're going to go on to the next one. Okay, so here's our first arithmetic sequence, and I've told you right now that it is arithmetic. So we don't have to worry about if it's arithmetic or geometric. I know it's arithmetic. And I can see here that I know what a sub 1 is. It's 29, so you need to write that down. And we're also putting in plus 5 right there for that blank spot on number 5. So first of all, we want to find the first 5 terms in the sequence. Well, given the recursive formula, you already know the first term, and you also know that you're adding 5 every time. So we know our first term is 29, and then we add 5 to 29 to get our second term, which is going to be 34. And then 34 plus 5 is 39. 39 plus 5 is 44. And then 44 plus 5 is 49. So those are the first 5 terms in the sequence.